Fusion is about combining nuclei. That's correct. So,
And fission is separation, right?
yeah, fission is splitting the nucleus of an atom, and you break it up into really big chunks. Yes. I'm sure I can. How's that work?
It's one balance.
Okay, well, I need more information when you ask me a question, okay?
You don't have a tip? You don't have one?
It's H2O.
Oh, I do, but I kind of want you to be a little more specific about what you're asking. What particularly are you struggling with that?
Because it's one of those ones where you gotta like keep on erasing the oxygen and stuff, like multiplying and adding all that. It's just a bunch of all the
Number-
numbers.
Which one?
95.
95. Okay. You just got here.
I really just got to school, and I hadn't heard your class because I got here.
So you just came to school and now you couldn't get here 5 minutes earlier and go to the bathroom?
No, because we was leaving the Waffle House late, and I hadn't heard.
You went to the Waffle House and you couldn't go to the bathroom?
You should just said you was a little white.
OMG! Yes, go to the bathroom. Golly, come on, girl.
I wasn't going to come. But I said I don't want to mess up my teeth.
All right. Number 95 is Na2
This balance.
CO3. Well, you got a practice test, don't you? You can read it too. All right? Let's see. We got plus PD NO3 4. And then on the other side of that arrow, we're going to have NaNO3 and PD CO3 2. Okay. I'm sorry, PD. Yeah, thank you. PD. Okay. You need to be very careful when you read these. Okay. It says, be sure to include the physical states in the equation above if the reaction takes place in water. That's really important because what that means is you've got to look up whether or not these are going to be aqueous or not. There is water around. We need to know if it is soluble, and if it is soluble, then you're going to determine it will be aqueous. Okay, so let's look for sodium carbonate then. All right, so if you look on the solubility rules, it says that all group 1 salts, well, sodium is in group 1. It's in the first column of the periodic table. That's group 1. So this is a group 1 salt. All right, it's a salt because it's an ionic compound, and you know it's an ionic compound because you have a polyatomic ion in the formula. Okay, so since this can dissolve, it's soluble, it can dissolve. If there is water, it will dissolve, and we're going to say that it's aqueous. Okay, Darrell, you had a question?
I want to know, do we use references on the exam?
You can use references every time you take a test in here, test or exam. Okay? All right, so let's look now at PdNO3. So that's lead nitrate, lead 4 nitrate to be exact. Okay, so let's see, nitrates. All nitrates are soluble, and there are no exceptions here. So that must be a soluble compound, and since it says in the question or the prompt that there is water around, it will dissolve, and we'll call it aqueous. Okay? Well, then we should already know that this is going to be aqueous because group 1 salts and nitrates are aqueous if there's water around, so we'll put aqueous over here. This is the one we've got to check on now. So lead is not, I'm going to just speed it up here by telling you lead is not included in the activity series, but carbonates are. Carbonates are right down here on the very first row of the insoluble section of the solubility rules. It says carbonates are insoluble. There's an exception for group 1 carbonates and ammonium carbonates, but this is lead, not group 1 or ammonium. Therefore, this can't be soluble, and even if there's water around, it's going to be a solid.
Bless you.
All right? So we've figured out the physical states. Now we're ready to determine if a reaction is going to occur, and if so, balance the equation. Okay? What type of chemical reaction do we have here? What classification is it?
It is not combustion.
It's not combustion because there's no, yes, it is double replacement. But back to the combustion thing. For it to be combustion, you would have to have a hydrocarbon fuel and O2, oxygen, and we don't have that. But we have a 2-part chemical here, and we have a 2-part chemical here. So that tells us there's going to be a double replacement reaction. And if we just do the A, B, C, D thing, we can find that here's A, and A should go with D, and sure enough, this is D, nitrate is D, and then C should go with B, and sure enough, C is lead, so that's C, and B is carbonate. Okay? So this is double replacement. All right? Yes, sir.
I don't know how you sub, how you get them. I know you're supposed to bring it back over to how it's coming iron, but is the case you're not bringing it over already, but you need to have an equation, how you do it?
I'm not sure I understand the question.
You see you got CO, Mid-3, and Mid-2, right? How do you get those?
Well, this was given to you in the problem. Number 95 on your practice test,
That's how it is.
this was it. That was given to you in the practice test.
I'm talking about you got to get the product.
You got to determine the products. That's true, but in number 95, the products were already given to you. But we could. All right, let's look. If it's two-part chemicals on the left, then the front part of this chemical has got to go with the back part of that one. And the front part of this one needs to go with the back part of this one. And so that's what you write over here. Okay, you just put them together and then you figure out how to balance them. But now, I would not have given you this to predict the products for because I don't ever give you a case where the oxidation number changes, and in this case the lead oxidation number is changing from left to right. Okay, so we don't do that in this class. I'm not going to throw that one at you like that. Okay? All right, we're ready to balance the equation then. So we need to write out all of our elements. Na, C, O, P, D, N. Then we want to do our sort of spreadsheet or grid or chart in order to do an atom inventory. Okay? Atom inventory here. Remember, we're putting this middle line right there underneath that arrow so we can show everything on this side of our atom inventory comes from this side of the equation. Everything on this side of the inventory comes from this side of the equation. We're ready to go and count all the elements. The subscript 2 following Na tells us there are 2 sodiums. There's no subscript following the carbon, so there must be just 1. The subscript 3 following the oxygen tells us there are 3 oxygens. Say what?
Well, yeah, you got
Well, now, hold on. We'll get there. So lead, that's right. We got it. So we got 3 oxygens here, plus we got all those over here. So let's do some math. Okay. So we've got 3 oxygens here, and then here this subscript 3 tells us there are 3 oxygens, but outside the parentheses we have a 4. So everything inside the parentheses gets multiplied by 4. That means there are 12 of those. So we've got a total now of 15 oxygens. Okay? So it's really 15 we're starting with. All right, so we do have 1 lead, and again, this 4 outside the parentheses multiplies everything inside. There's no subscript after the nitrogen. That means in this polyatomic ion here, there's 1 nitrogen, but that gets multiplied by 4. Okay? All right, then we go to the other side of the equation. We've got 1 sodium here. We have, for the same reason we were explaining how you get the math here, 2 times everything inside, 1 carbon, so that's 2 carbons here. the oxygens, we've got 3 oxygens here, plus the 2 times the 3 here gives us 6. So we've got a total of 9 oxygens right now. Okay? We've got 1 lead and 1 nitrogen. We're going to save oxygen for last, and we're going to save hydrogen for next to last, but there isn't one. So all we have to do is worry about leaving oxygen, balancing oxygen last. So let's start with sodium. It's the one at the top that's unbalanced. Once the formulas are balanced, and these are already balanced, and the only thing you can use to get the same number of elements on both sides when balancing an equation is or are coefficients. Okay? So I'm sorry, it shouldn't be a 3, it should be a 2. 2 NaNO3. So that gives us 2 NAs. It changes the number of nitrogens to 2. I'm sorry, yeah, 2 down here. That also changes the oxygen. So I've got 2 times everything here. That's that coefficient out in front. Multiplies everything inside. So it's 2 times the 3 oxygens we have for 6 oxygens there, plus the 6 over here. We've got 12 oxygens right now. Okay? Alright, so now we can go to the next thing, and that's the carbon. We're going to save oxygen for last. We're going to go to carbon next. I've got 2 on the right side, only 1 on the left. So I need to go back over here and multiply, put a coefficient out in front of whatever contains the carbon, and that multiplies everything inside. So now we've got to recount. 4 times 2 NAs will give us 8 NAs.
How do you get the 4?
Oh, I only need 2, don't I? I need 2. That'll be a 4. Okay? So that'll be a 4. All right. And let's see, that's going to give us 2 carbons. And oxygens are going to get complex. We've got 2 times 3, that's 6. And 3 times 4 oxygens here is 12 for 18 oxygens. Okay? Well, we unbalanced the sodiums, didn't we? Right? We got 4 here. In order to get the carbons to balance out, we had to have an extra one. So we've got to go back over here and fix that now. Let's make this a 4. Now we've got 4 sodiums. We have 4 nitrogens. And we have 4 times 3, or 12 oxygens here. 3 after the oxygen tells us there are 3 here, times the 4, that's 12. And we have 3 in this, or 3, the coefficient 3 after the oxygen tells us there are 3 oxygens here, times is 2, so that's plus 6, or 18 oxygens. And I think we're done, aren't we?
Yeah.
Yes, sir. I'm sure I can. Is everybody satisfied with what I did here? Does anybody have any questions about balancing this particular kind of equation? All right. You want to do all of those?
How come you get like 6 after
What
question? We only get 1.
What?
That's still
But you gonna be asking them that many questions every time?
I know, but how come you do so many in a row? You know what I'm saying?
You know you're supposed to do one at a time. That's why I'm asking. You want me to do all those?
What number? What is it?
He wants me to do all of them from 10. Which one?
101 to 108.
That's the label and the
105 through 108.
Ooh, 3 questions.
Well, let me get one that I haven't already marked on.
I hate asking an easy question. Everybody jump in. How'd you do?
Apparently I was using that to help somebody already. Okay. Tell you what, let's do.